Hello students, today we are going to learn that how to find out the rate of a reaction. Let's take one example. If you take a reaction in which R forms P, let R be the reactant and P is the product. So reactant is forming product, this equation we have taken. So we can define the rate of reaction as we can state as change in concentration, change in concentration upon time taken. Means whatever concentration was there initially, what change has happened in that, and for that how much time was required divided by time interval. So for this given equation R forms P, we can write the rate of reaction as rate of reaction is equal to change in concentration of reactant divided by change in time, or we may also write rate of reaction in terms of products concentration, and that would be change in concentration of product upon change in time. Now you may wonder that why I have written negative sign along with the reactant but not with the product. So with the reactant, negative sign is given. Reason for that is reactant concentration decreases with time. Okay, so let's draw a graph for this. Let's see. So on the x-axis will take time and on the y-axis will take concentration. Concentration of reactant was present initially, it will decrease with time, whereas concentration of product will increase with time. Okay, so if you take two time intervals, let it be first T1 and the second one be T2. Okay, so this is T1 and this is T2. So the graph which is starting from the origin, that it will be for the product, and the one which has started from the top, it will be of reactant. So we know that as the reaction moves ahead, concentration of reactant will decrease, whereas the concentration of product will increase. So initial concentration of reactant was this, let it be R1, and this is concentration of reactant at time 2, that is R2, whereas for product this will be P1 and this will be your P2. Okay, so when you find del R, you will get it as R2 minus R1, but R2 is a smaller value than R1. That means delta R will get as a negative value. But when we find the same thing for concentration of product, again we'll do the same thing, concentration final minus concentration initial. So final is P2 and initial was P1. So P2 minus P1, this time it will be a positive value. That means the negative sign in the expression of rate of reaction with concentration of reactant is written to show or symbolize that concentration of reactant decreases with time or with the progress of reaction. So we can mention negative sign symbolizes or signifies decrease in concentration of reactant with time. With time. Okay, this we can state. Now let us take one general equation that if some coefficient will also be available, then how we can write the expression for rate of reaction. So for that we'll take one general equation as A into A plus B times of B forming C times of C plus D times of D, where capital A and B are reactant, capital C and D are the products, small a, B, C and D are coefficients. So for this reaction, rate of reaction will be equal to, with reactants will take a negative sign, reason being they are being used in the process. So minus 1 by A del A upon del T is equal to minus 1 by B del B upon del T is equal to 1 by C. Now, since the product is being formed, we don't have to include a negative sign with that. 1 by C, change in concentration of C upon change in time, and that would be equal to 1 upon D, change in concentration of D upon del T. So if you have value of any of the four, whether of A, B, C or D, you can find out the rate of reaction by using the expression. Okay. Sometimes they will also ask that what is the rate of consumption of reactant or what is the rate of formation of product. How to obtain that? Let's see. So if you mention minus del A upon del T, this is called your rate of consumption of A. Rate of consumption of A. So when rate of consumption of A was divided by the coefficient small a, you got the rate of reaction. That means rate of consumption of A may also be written as A multiplied by rate of reaction. Okay, so if you have the rate of reaction, you can multiply that with the coefficient small a, you'll get the rate of consumption of A. Likewise, we can find out rate of consumption of B. Rate of consumption of B and that would be equal to B multiplied with rate of reaction. Rate of reaction. Okay. Similarly, we can go for the other two parts, that is for product C and D. For that also we can write. So del C upon del T. This would represent rate of formation of C. Rate of formation of C. This will be equal to C multiplied. This is small c. Okay. Not the capital one, small c. Coefficient C multiplied with rate of reaction. Rate of reaction and change in concentration of D upon del T. This will be rate of formation of D will be equal to D multiplied with rate of reaction. Okay, so this is how you find out the rate of formation, rate of consumption, and rate of reaction if some of the values are given. So let's take one example to understand this and solve the problem. So here we have a problem which says for a reaction N2 gas plus 3H2 gas forming 2NH3 gas, if concentration of H2 changes from 0.2 molar to 0.01 molar in 10 minutes, then find out rate of reaction, rate of consumption of N2 and rate of formation of NH3. So what we'll do first, we'll write the expression of rate of reaction. So rate of reaction is equal to change in concentration of N2 upon change in time is equal to minus 1 by 3 change in concentration of H2 upon change in time, because with H2 we have coefficient 3, that would be equal to 1 by 2 change in concentration of NH3 upon change in time. So this will give us, now we have been given the concentration of H2, it is changing from 0.2 to 0.01. So how to use that? We can use the expression for that. Okay, that will give us the rate of reaction. So rate of reaction will equate it with minus 1 by 3 del H2 upon del T, that will be minus 1 upon 3, 0.01 minus 0.2, and the time interval was 10 minutes divided by 10. So when you calculate this 0.01 minus 0.2, that will be minus of 0.19. So that has to be divided by 3 into 10, that is 30. So that will give us 0.006, and minus will multiply, it will become a positive value. So we'll get 0.006 mole per liter per second. Okay. Once you have got the rate of reaction, you can find out the rate of consumption of N2 and you can find out the rate of formation of NH3 with the help of equation itself. So rate of consumption of N2, that is minus del N2 upon del T, is equal to rate of reaction. Rate of reaction. So that would also be equal to 0.006 mole per liter per second. All right. Whereas rate of formation of NH3, that would be equal to 2 multiplied with rate of reaction. So that would be equal to 2 times of 0.006 mole per liter per second. That means we'll get it as 0.012 mole per liter per second. So this is how you can find out the rate of reaction if some concentration change is given to you. Okay, so you can try some more problems on this. In the next video, we'll do some other topic from the same chapter. Thank you.